One of the boldest moments in AI hardware just happened and almost nobody noticed. Groq, a scrappy AI chip startup, turned down Nvidia's offer to acquire them, then walked out the door and raised $650 million on their own terms. This isn't just another funding round. It's a direct challenge to the chip giant that's dominated artificial intelligence for the last 3 years. And here's what makes it wild. Groq's entire bet is on something Nvidia has been ignoring: inference speed. The ability to run trained AI models faster than anything else on Earth right now. So why would Nvidia want to buy them? And more importantly, why did Groq reject that offer? The answers tell you everything about where the real battle for AI is shifting. It's not about training anymore. It's about who can run AI models the fastest at scale. That's worth billions in real revenue. And Groq just bet their entire company that they can beat Nvidia at their own game. Stick around, because you're going to understand exactly why Groq's technology matters, why Nvidia actually needed them, and what this means for every company building AI products right now. Let's start with the fundamentals. Groq was founded in 2016 by a team of ex-Google engineers obsessed with a single problem: inference speed. Here's what that means in plain English. When you use ChatGPT, two completely different things happen inside the machine. First, someone trains the model. That takes weeks, costs millions of dollars, and happens once. Engineers feed the system billions of examples until it learns patterns in language. That's training. But when you actually ask ChatGPT a question, the model's already trained. It just needs to push your words through all those learned patterns and generate an answer. That's inference. And while Nvidia spent the last decade dominating the training market, making bigger, more expensive chips, Groq made a bet almost nobody else made. They said, "We're ignoring training. We're going to build the fastest inference chips on Earth." Think of it like two different racing strategies. Nvidia built the fastest pit crew and the most powerful engines. Groq said, "We don't care about pit crew. We are designing a car that finishes the race in half the time." They built a custom processor architecture called tensor streaming, and what happened shocked the industry. This is where the real story gets interesting. Here's the technical magic behind Groq. Most AI chips, including Nvidia's, rely on something called memory hierarchy: fast cache, slower main memory, even slower storage. Data has to bounce around between all these different levels. It's like a chef who has ingredients in different parts of the kitchen, so they are constantly running back and forth. Groq's tensor streaming architecture works completely differently. Instead of bouncing data around, they stream it directly through the processor in one continuous pipeline. All the computation happens in a single flow. Same chef, same ingredients, but now everything's arranged in a line so they walk through once and they are done. The result? Groq's chips process tokens, the chunks that make up AI text, at absolutely stunning speeds. We are talking 500 to 700 tokens per second on models like Mixtral 8x7b. Nvidia's high-end data center GPUs, they max out around 50 to 100 tokens per second for the same model on the same hardware cost. That's not just faster, that's 5 to 10 times faster. And in the AI business, speed directly translates to cost. If you can run inference 10 times faster, you can serve 10 times more customers on the same hardware. For cloud companies, that's a complete game changer. But wait, there's something nobody's talking about. Numbers matter here, so let's get specific. A company running a large language model on Nvidia GPUs might see a response time of 100 to 200 milliseconds per user query. That's a fifth of a second, fast enough that it feels instant, but slow enough that if you're serving millions of users, you need thousands of servers. Now put the same model on Groq's chip. Response time, 10 to 20 milliseconds, 10 times faster. For a company like, say, an AI startup building a customer service chatbot, that means running the entire system on a tenth of the hardware at a tenth of the power consumption. Or here's another example, an enterprise running internal AI tools for document analysis. On Nvidia, processing 1,000 documents might take an hour. On Groq, same documents, same quality, 6 minutes. And that's not theoretical. These are benchmarks from independent testing. Now multiply that across 1,000 enterprises, and you can see why Nvidia panicked. They weren't afraid Groq would beat them at training chips. They were afraid Groq would eat their lunch in inference, which is where the volume is. Every company running AI models is running inference millions of times a day. Training happens maybe once a year. This is where the real economics of AI live. And this is where Nvidia realized they had a problem. So how does Groq actually stack up against Nvidia? Let's be honest, they're not competing on the same battlefield. Nvidia's A100 and H100 chips are monsters. They can train the largest models in the world. They can run any workload. They are flexible. Groq's chips are specialists. They absolutely crush inference speed, but they are less flexible. You can't train large models on them, and some specialized workloads might not run well. It's like comparing a Swiss Army knife to a high-speed drill. The drill is way better at drilling, but it doesn't do anything else. However, and this is huge, the market has figured out that inference specialists are exactly what they need. Microsoft, Google, and Amazon all run pre-trained models. They're not building new models every day. They are running the same models on the same hardware billions of times. In that scenario, Groq's weakness becomes irrelevant, and its advantage becomes everything. Nvidia knows this. That's why they tried to buy Groq, control the inference market, and you own the future of cloud AI. But Groq said no. And more importantly, they proved they didn't need Nvidia's money. They raised $650 million from investors who believe inference is about to be the next trillion-dollar race. Here's what that really means. For a decade, Nvidia had the AI chip market locked down. Want to train an AI? Buy Nvidia. Want to run an AI model? Nvidia. No competition that mattered. They controlled 95% of the market and charged accordingly. A single H100 chip costs $40,000 to $50,000. A single A100 costs $10,000 to $15,000. That's not a product. That's a tax on anyone who wants to use AI. But inference is different. Inference runs billions of times. If you can reduce inference cost even slightly, the total savings become massive. A company running large language models across millions of users suddenly has a 10 times advantage if they switch to faster inference chips. That's not a feature upgrade. That's a complete rethink of the entire business model. Now Nvidia isn't just competing on performance, they are competing on price per token. And on that metric, they are losing. This is the first real threat to Nvidia's dominance in a decade. It's also why they tried to acquire Groq instead of competing. Nvidia's management probably thought, we can't outsmart these engineers at their own game, so let's just buy them and kill their products. Groq said no, and that's forcing Nvidia to actually innovate. For the first time, Nvidia has to make chips that aren't just powerful, they have to be efficient at inference. That's not easy when your architecture was built for something else. But here's the thing that changes everything. If you're building an AI product right now, this matters to you directly. You've got choices for the first time. Until Groq, if you wanted to run an AI model in production, you had basically one path: buy Nvidia's hardware, pay their prices, and accept their margins. Now you have an alternative. Groq is selling inference time through partners and cloud providers, which means if you're deploying AI, you can compare options. Nvidia's chips are still the safest bet if you need flexibility and have unlimited budget. They work with everything, but if you're running specific models at scale, like serving a language model API, Groq becomes interesting. The math is simple. Do the benchmarks. How many tokens per second do you need? What's the cost per token on Nvidia versus Groq? The difference might be so big that it justifies retraining your deployment pipeline. For most teams, that's about an afternoon of engineering work. The second thing that changes is vendor leverage. Before, Nvidia owned you. Now you can say, hey Nvidia, your H100 is 10 times slower than Groq for my use case, so either cut your price or I'm leaving. Suddenly engineers have power again. That's good for the whole industry. Third, it opens the door for other specialists. If Groq can beat Nvidia at inference, what about other workloads? Training large models. Fine-tuning. What if another startup shows up with chips that specialize in something Groq doesn't do? The monopoly is officially broken, and that's driving change across the entire industry. So here's what you should take away from Groq's $650 million vote of confidence. The AI hardware market is not settling, it's splintering. We're not moving toward one winner anymore. We're moving towards specialists who own their slice. Nvidia will still dominate training because they've built the ecosystem and the software. But inference, that's going to be competitive. Groq proved it's possible. And now every AI company is going to have to choose. Do we need speed and efficiency, or do we need flexibility and ecosystem support? Most big companies will hedge and buy both, but that's the opposite of the monopoly Nvidia had. The second insight is about capital and timing. Groq turned down Nvidia's money because they didn't need it. That means the market has fundamentally changed. 3 years ago, being acquired by Nvidia would have been a victory. Being bought by Nvidia meant validation, resources, and safety, but Groq thought their product was worth more independent. That's a statement about founder confidence and investor demand. Venture capital is betting that the inference market is so big that building a specialized company around it beats being part of Nvidia. That usually only happens when the market is about to explode. The third insight is competitive pressure. Nvidia will not stand still. They'll either build faster inference chips, cut prices, or both. That's how markets work.